Here we're going to do another example of sketching a graph of a quadratic function using its key features. So we're going to find the y-intercept, the x-intercept, and the vertex and use those things to graph this parabola. So the first thing we're going to do is to find the y-intercept. That is always the easiest thing to find because it's when x is equal to 0, right? So we're going to find f of 0. And of course, once we fill in all the x values with 0, we're going to get an output of 2. So the y-intercept is 0, 2. And the x-intercepts, now, is this factorable? If we were to set it equal to 0, factors of 2 that add to -4, 2 and 1 is 3, or -3, but we're never going to get quite to -4. Okay, so here's what I would suggest. Let's find the vertex first. So I'm going to take the initial function here, x squared minus 4x, and I'm going to complete the square on that. Now 4 is kind of a funny number. When you divide it by 2 and square it, 4 divided by 2 is 2, 2 squared is 4. So you end up adding the same coefficient on x, right? So you have -4 minus 4 plus 2, right? So we're going to factor this trinomial here, and the square root of 4 is 2, right? And we're subtracting, so we've got x minus 2 quantity squared. -4 plus 2 is minus 2. Okay, so the vertex is 2, -2, right? We're subtracting 2 inside, so it's moving to the right, so our x-coordinate is positive, and down 2, right? So our y value is negative there. Okay, so now my idea here to find the x-intercepts is that if we have f of x equal to x minus 2 quantity squared minus 2, if we set this equal to 0, maybe those intercepts would be a little bit easier to find given that this wasn't factorable. So the first thing I'm going to do is I'm going to add 2 to both sides, right? So I've got 2 equal to x minus 2 quantity squared. And then I have to take the square root of that. So I'm going to have plus or minus 2 equal to x minus 2. And then I have to add 2 to both sides, right? So 2 plus or minus square root 2 is equal to x. With a value like this, if we're going to graph it, it's better to find an approximate value for the square root of 2 in there. So I really have two values here, right? 2 minus the square root of 2, or 2 plus the square root of 2, right? And so if I go to just Desmos, or if you have a scientific calculator of some sort, and you just plug these in, right? The calculator will give you approximately 0.586, and for 2 plus square root 2 we get approximately 3.414. Okay, so those are the intercepts, right? 0.5860, right, is a point on the graph, as is 3.414, 0. So I'm going to use these points and plot this function. So I've got 2, -2, right? The y-intercepts, of course, this is just eyeballing it off the graph. It's right around a half, right? And then we have 3.414, so right ahead of 3.5 there. Okay, so and then the y-intercept is 0, 2. Okay, so I'm going to look at the axis of symmetry here. It runs right through the vertex point. Notice that the x-intercepts are about 1.5-ish units away, right? And the y-intercept is exactly 2 units away. So if I go over on to 2 units on the other side of the axis of symmetry, I have another point there, because quadratics are nice and symmetric that way. And then I'm going to connect the dots. Okay,